Good morning, everyone. Hope you've been enjoying the conference. This morning, I appreciate everyone coming out to listen about CDNs. I've kept it pretty high level across a bunch of the concepts that you might like to know if you haven't encountered CDNs before, or even if you have, I'd like to kind of fill in a couple of the gaps for you. Just to get started, CDNs are something that powers the internet. It's something that's almost transparent. You don't know is there, but they power up to kind of 50 to 70% based on current stats of all traffic on the internet. That's way, way higher for streaming videos, like well above 90, 95%. During COVID, CDNs were kind of such a crucial part of the internet infrastructure, making sure that we could to jump on video calls and all of that and everything surviving. If you haven't kind of used CDNs and leveraged them, it's kind of one of these tools in your toolbox that when you start realizing the power of what you can do with it, it's pretty impressive. So what I'm going to go through today is kind of a bit of the high-level agnostic concepts between all the different CDNs. I've tried not to go into any particular brand or cloud provider, but I'd rather give you the concepts and kind of the basic building blocks you'll need to be able to navigate what CDNs are and how to use them across the various different cloud networks. Bit about me. My name's Jake Ginnivan. I'm from Perth in Western Australia. It's awesome to be back up this side of the world and seeing a whole lot of people I haven't seen for a long time. I'm a principal consultant at a small consulting company called Arcana. We're only about 2 years old, and we mainly focus and play in the Microsoft space and do outcomes-based consulting. So I really enjoy that aspect where I get to work with my customers to make sure that I am getting outcomes rather than fixing scope and that sort of stuff. Hit me up on Twitter. I'll also be around the conference, just hanging around for the next day and a half. So feel free to hit me up if you've got any questions or want to chat. I want to go through a bit of the what and why of CDNs. That's where I'll spend the majority of my time. There's this concept around edge computing, give you kind of the understanding of what it is and how it works and how you can leverage it. And then I want to take a step back and talk about HTTP fundamentals, because at the end of the day, CDNs help you serve your HTTP content predominantly. And then finally, I want to get into some tips and tricks and gotchas, because using CDNs and any sort of caching comes with potential risks. So I want to kind of highlight some of the problem areas that come with using a CDN and some of the ways to get around it. Let's dig in. What is a CDN? Well, let's break down the words. It stands for Content Delivery Network. If we break that apart, there is a bunch of content we like to serve, so HTML, images, JavaScript, video, all of those sort of things. So it's just what is the content your website is serving up. Delivery is normally, the mechanism is HTTPS, and it provides a lot of nice services around that. But the really interesting part is this network. CDNs have this backbone network that we'll jump into a little bit later. If we look at the world, I am from Perth in Australia, and I might have a point of presence in my data center kind of on the east coast of Australia. So I'm hosting my website there, and we're up here in Oslo, and all your ISPs, so your phone, they often have what's called a point of presence. It is a server in your ISP or local data centers that is a point of presence for this CDN network. And between that, these networks have their own CDN backbone. This is where this first kind of area of advantage is. So with the CDN network, they can intelligently route traffic because it knows where your origin server is, which is where you're hosting your website, and you've got your edge server or your point of presence, and it knows how to navigate the internet effectively. And in fact, it stays off the internet to use these private CDN networks to avoid all sorts of issues, like if there is a lot of congestion on a particular switch it knows how to route around that and that sort of thing. So that's kind of the idea. But there are lots of points of presences. If you have a look at your Azure or AWS and have a look at the regions, there's only a kind of a handful of regions, a couple of dozen regions, but there are tons of these points of presence all around the world. And that's kind of the what of it. Where it's much more interesting is the why. I like to jump in and talk about kind of the whys of things. And I got to know about the whys when I was working at a news company in Australia called WA News. My team helped build the west.com.au, perthnow.com.au, and 7news.com.au. So 3 news websites. 7 News was the biggest at the time, and when we were building it, it was probably about 70 million page views a month. So not a massive news website in terms of some of the global scales, but still a decent amount of traffic. Learned a lot of little things around how to leverage CDNs to keep costs under control and that sort of thing. But one of the biggest costs is data. If you use AWS or any of the clouds, you might, and you are serving any sort of volume of traffic, you've probably noticed that egress, how much you get charged for data going out of the data center to the customers or end users, it can get super expensive. One of the things that we kind of learned really early is JavaScript bundles sizes. If you've been to a news website and you've seen like this article was published 3 hours ago, that relative time problem. If you are trying to target, say, Internet Explorer 11 at the time, one of our devs installed a polyfill. It came with about 600K of translations, like what is Wednesday in every single language. So that blew out our bundle size, and it ended up costing us tens of thousands of dollars over a couple of weeks because we just didn't notice that our bundle size had popped up. By the time we noticed it a few weeks later, it had already racked up a massive bill. So you can kind of, when you're serving these great volumes of traffic, it's pretty easy to rack it up. So what sort of egress costs are around there? Well, this is one of the first benefits of CDNs. Your CDN egress is with, say, AWS is immediately cheaper. So your standard, if you're just hosting on EC2 or any other service, you're paying about 12 cents US a gig. As soon as you put CloudFront in front of it, that drops to about 8.5 cents per gig. So just by putting a CDN in front of your application and serving, you get immediate cost savings. And also, as you serve more traffic, those cost savings get far, far better when you are talking about like the price tiering. Azure is much the same. The egress is slightly more expensive on Azure, but you're looking at about 18 cents US per gig, and that drops down to about 12.5 cents per gig as soon as you put a CDN like Azure Front Door in front of it. The other really interesting one is Cloudflare, where egress is free. Now, one of the things about Cloudflare is often you will use it with another provider like Azure or AWS. So you will still have to pay egress between, say, Azure and Cloudflare, but they have bandwidth agreements in place, so you'll get a discounted rate when sending traffic from, say, Azure to Cloudflare. There's some really interesting blog articles around kind of the egress costs and how to leverage all of this stuff, which we'll cover a few of those later. Another example of kind of a cost blowout. Who's seen on the site Have I Been Owned by Troy Hunt, who's often, so Troy builds this site, Have I Been Owned? You put in your email address and it tells you, has my email address been included in some sort of data leakage event? He had an issue a little while ago where he noticed his bill came through and he's like, whoa, I've got $4,500 Australian of egress costs on my storage account. It's normally cents. What's happened? And this is one of the really nifty things about CDNs, is you can control these if it's all configured properly. It's a really interesting read, but essentially one of the concepts we're going to cover pretty soon around caching, for some reason it no longer was having cache hits in the CDN, so all of the traffic was going back to the origin server, and he wasn't getting any of those kind of bandwidth savings of having Cloudflare giving free egress. So suddenly his costs went up and ended up costing a fair bit, but Microsoft and Cloudflare came to the party and covered his bills for him, and that was really, really nice of them. So can recommend having a look at that blog post, how I got owned by my cloud costs. It's a good one, and a lot of the concepts we'll talk about today, when you go read that blog post, it's kind of that next level of detail down. It's a good read. So caching. This is kind of one of the primary reasons that people use CDNs. Let's say I am going to the NDC agenda page for my talk. I visit it with my browser. It then hits the point of presence and goes back to my origin server. Gets the response. I can include a cache control header when we get to the HTTP fundamentals. I'll explain some of these a little bit more, but I can return a cache control header, which basically says this is good for that many seconds, 3,600 seconds, and that instructs the CDN that you can save that and serve that same content to other people. So when the next lots of people come along, it immediately just returns the same response to those if they have hit the website within the next minute. So if you've got any sort of content that is allowed to be a little bit stale, it's a perfect scenario. Just turns one of these TTL time to live caching on, and then suddenly you just reduce your origin server by a huge amount. For news sites, we are getting people hitting the homepage all the time. Like, people just have it auto-refreshing. And so just by putting a minute or 2 minute time to live on that homepage, suddenly our traffic on our origin server, which means we have far less instances, our compute costs go down, all of that sort of stuff, suddenly all of that just drops dramatically. So that's kind of your first little thing that you'd like to do is turn on caching for anything you can. Prime candidates of this is like your JavaScript and images and any kind of static assets. Immediately you can, for your single page apps, is a really good target for those sort of things. You can start leveraging this caching to improve reliability as well. Let's take the same scenario. I've cached it, but instead I'm returning a different cache control directive, which says, I want you to serve stale if there's an error for the next minute. What's nifty about this is the second person can come along and it will still go back to my origin server. So I haven't said to the CDN that you're allowed to serve stale or cached data. So we'll always go back to my origin server, except let's say my CDN or my origin server catches on fire. Now a whole bunch of people are hitting the website, they want to see the agenda. The CDN will go to my origin server. That won't work. Can't contact it. Because I've said you're allowed to serve stale if there's an error, it will just return the last known good copy of my website. This is incredibly handy. Because we were distributing a news website, and we want news to be up to date, but we also wanted our team to be super efficient. So what we did is we moved towards continuous deployment, where anytime our team would merge a pull request, that would go straight out to production for these 3 news websites. Sometimes things went wrong, and we had a Sev one. It might have been something blew out the CPU usage, or it could have been like an error that we just didn't catch. Because we're going out, this saved us a lot of time. So we decided that we would let our team leverage the CDN, allow our origin to go down. Because we could redeploy any fixes in kind of 5 to 10 minutes, we moved towards being able to detect the errors really quickly and then fix them fast. Different industries, you might not be able to do that because you can't afford to actually be down, you can't cache the content, but for us it was a great trade-off. Latency. This one is kind of leveraging the network side of things. So when I visit the website, it's got my point of presence. I mentioned earlier that you enter the CDN's network. These are incredibly sophisticated networks. Because they understand their worldwide network, they intelligently route traffic. So if there's a massive event, for instance, it will, and there's a bunch of congestion in a particular region in the world, that the switches are overloaded, things are getting slow, it understands the throughput of its entire network and can intelligently route around it. A little bit like your GPS can route around traffic problems and give you the most optimal route. CDNs have that aspect to it. So just because you aren't traversing the internet and it understands its own network, you can just avoid a whole bunch of reliability issues. And between, say, Oslo and Perth, it's about 250 milliseconds of latency. But these networks can bring that down just because they route so much more efficiently. But what's really nifty about this network is they are also a load balancing or a reverse proxy, where I can have multiple origin servers in different locations around the world. Now, the really cool thing about that is you can instruct your CDN that for any point of presence, I want you to route to the origin server that has the least ping. So now you can have your multiple regions, and your CDN can automatically route or hit the origin server that is closest to the user, reducing latency. But then if that origin server happens to go down, it just will direct traffic to the other service. So it gives you that kind of flexibility and continually tries to reduce the time to getting your website to those users. There's a lot of literature around this, from Google and whatnot, around the impact of how much it can improve conversion rate, reduce bounce rate, and those sort of things if your website loads faster. So all of these things, just little wins that help your website load a bit quicker. Another one is DDoS protection. So distributed denial of service attacks are getting far, far larger and more problematic. And essentially, one of the reasons for that is we've got all of these old Windows XP boxes from all around the world that have like little bots running on them that anyone that controls one of these bot networks can suddenly just turn them all on and start hitting a website to try and bring it down. But it's not just bringing it down, the reliability that denial of service attacks can actually hurt you. We've talked about egress costs, and there's also compute costs if you're using serverless. Because of the elastic nature of cloud, if you're getting a distributed denial of service attack against your website, all of your infrastructure will probably scale up to kind of deal with this extra traffic. That means extra cost. It's quite easy for a DDoS attack to cost you a lot of money. So, like Cloudflare, for instance, earlier this year, they mitigated an attack against one of the clients on their network, and it was issuing about 71 million requests a second. So I don't know if your servers can handle that. I certainly do not want to be running that amount of infrastructure. Microsoft also last year had one where they mitigated an attack of about 3.5 terabits per second, which is about 133 gigs per second of just inbound traffic. These networks can absorb a massive amount of traffic. It's quite impressive. But one of the really cool things about when you sign up for a CDN, and if you go to some of their premium SKUs and pay for the better DDoS protection, a lot of what comes with it is insurance policies. Like if you are using AWS CloudFront and use their Shield product, any additional cost that you incur on your AWS bill due to like a DDoS attack, they will cover it as kind of an insurance policy from your CDN. So have a look into that, because it can kind of be a really useful financial protection for you and your company if you are running that sort of stuff. Flexibility. We can have, let's say I have the agenda page again, and it goes, I load it up, hits my origin server, serves up the HTML. Inside my CDN, you can actually configure a whole bunch of rules. So I'm going to configure a routing rule here where I said everything that's under the static folder, I instead, like a JavaScript file for instance, I want to route that to a storage account or S3 or something like that, because those are services that are optimized for serving files, and that means my origin server or my web server doesn't have to serve up files, which most web servers are not as good at doing that as, say, S3 or another storage account. So it gives you that flexibility to control, have multiple origin servers, and then route between them based on abstract rules. This is also super, super handy if you are, let's say you have deployments that require downtime. If you can stand up a second origin server that even hits the same database or however you do it, you can get your CDN to route all of the traffic over to one region, take one region off, the other region offline, upgrade everything, bring that region online, move it across. Other examples of this, let's say you are trying to move from a web stack like WordPress and now you want to run Next.js. You could use your your CDN to route different paths to each of the applications. So you can do a gradual migration between different platforms. There's a heap of things you can do, and this is one of the reasons, even if I'm not leveraging the caching ability of a CDN, I pretty much always put one in front just for its reverse proxy capability. So it gives you a lot of really nice ability to kind of adapt to any unforeseen issues that will happen over the lifetime of your application. Finally, we've kind of got logging and analytics. Just data is super, super useful, and at the edge, you're getting a heap of requests. Just being able to aggregate over that and see what traffic patterns you have against your website is really, really handy. So a lot of the CDNs have quite good insight products to tell you where all the traffic is coming from and categorize the types of traffic from bots to end users, where they were referred from. Do you getting referrals from Google or social networks or any of those sort of things? So, bit of a roundup. Oops. Cheaper bandwidth costs. You have caching. That gives you the ability to serve while stale, or if there's an error. There's a bunch of other cache control headers we'll jump into later. Latency improvements, leveraging that network, getting time to first byte and those other metrics that Google use to rank you if you are a public website and you are trying to improve your search rankings and that sort of stuff. Latency and time to first byte and those sort of metrics are quite important. And also just DDoS protection and the flexibility that it can provide. So they're kind of a bit of a wrap-up of the features and reasons why you would want to put it in. But just ones like egress, that you almost get something for nothing. It just makes a lot of sense. So the next thing I want to talk about, edge computing, is there's been a lot of interest in this area, especially with frameworks like Next.js and Remix, which allow you to deploy your web applications to the edge. I just want to point out that a lot of this, I mentioned this at the beginning, I don't want to try and tie myself to a particular CDN network. Each of them are quite different in their terminology and the way you implement these things. So I've kind of taken a step back to explain the concepts. And once you understand these concepts, you'll be able to navigate the documentation and figure out how to do that for that particular product. So that's kind of the approach I've taken. What we have here is our end user. You've got your CDN and the cache in the CDN, and then I've got my origin server. If I'm getting my website, the first thing that kind of the edge allows you to do is run compute. So you can have, if you're in AWS land or CloudFront, you can run a Lambda at edge or a Cloudflare worker. And it allows you to basically deploy Python or JavaScript or whatever the service provides into your CDN and run compute at various points of the life cycle. So the first thing is running compute before the cache. Now this is useful for a bunch of different scenarios, but the one I'm going to do is, let's say I have a paywall on my article and I have a user that logs in. I have a cookie that has their auth token. That token is a JWT. I run my edge function. Now, my edge function could look something like this, where I get the request in. I can use a JWT library to validate that that JWT was issued by me. A JWT, for those that aren't super familiar with auth, is a JavaScript web token, and it essentially allows you to prove that someone issued it. So if I am logging in with auth0, Auth0 will use a private key to sign the JWT, and I can validate that Auth0 issued that JWT without talking to that authentication server. So it allows offline verification of what the person is proving. So here what I'm doing is grabbing out the claim of the subscription level. So the token has a whole bunch of user information in it, but if I'm thinking about caching and I'm serving 70 million requests, if you think about a news website or a lot of public websites, you have a lot of people only visiting 1 or 2 websites. So if you cache per user on the home page, you essentially will never return a cached result because users are only returning to the website once a day or whatnot. So your cache effectively becomes useless. What I can do is I can extract their subscription level from that and set a header. And now, when my origin server looks at that header, it can render either a paywall or the unlocked article based on this header. That's super handy because I can just cache that header, and if I've got 2 different versions, so none or subscriber, I now have 2 versions of my cached website, the paywalled version and the unlocked version, and my cache becomes effective again. So this is a reason you would run compute before the cache, is to essentially modify the request to make the cache more efficient. So the next scenario, that's kind of got us to here, and then you've got the modified request, and then it checks to see if there's been a cache hit. We'll continue to say there wasn't, and the next piece of compute that we can run is after the CDN behind the cache. Scenario here is I am migrating, let's say, my blog from WordPress across to Astro, which is a new static site generator. It might be Jekyll or whatever the latest and greatest static website generator is. An example of there is I just want to do URL rewrites from the old one to the new one. So I can check to see if the URL coming in matches a WordPress URL. If it does, I will issue a permanent redirect to the new URL structure. Otherwise, I'll just let the request go through. This means I don't have to write this redirect logic into my origin server, simplifies things, and that will return the new URL. Whereas when I come in using the new URL after the redirect, that will go through to my origin server because it isn't one of the old URLs. And that's now on GitHub pages, so I'm not paying for it and that sort of stuff. So migrations are a really good example of when you would use compute behind the cache. So that's got us to here. You can also run compute before the response is sent. What's a scenario for that? Let's say I am serving images, lots and lots of images on my website. Now, browsers have different levels of support for different types of image formats. So Chrome supports WebP, but Safari doesn't. So for all my Chrome users, I want to be able to serve the most optimal image format for them. There is a header called the accept header that browsers always send, and it essentially says, these are the types of content that I support. Server, please return me a format that I know how to deal with. So if the request is coming in and it's got an accept header of WebP, you'll notice that even though the logo.png, you're asking for a PNG, it will send a whole bunch of accept headers for the other formats that it can receive. I'm also putting on a query string of w equals 300. We'll have a look at that in a sec. So my origin server is returning a PNG back to my edge function, and it's got dimensions of 1500 by 1200, so it's or 1000. So it's a large image, much larger than the user wants. I can write an edge function which grabs the accept header and goes, okay, if it's a WebP, I want the format of my response to be a WebP image. Otherwise, I just want it to be a PNG. If it doesn't support PNGs, drop it back to JPEG. So now I can my image function can serve 3 different types of images. I then use something like Sharp, which is an image manipulation library, and I can say, I want you to send back the image resized to this width, and it will keep the aspect ratio, so it'll still be in the same aspect ratio. I want you to send it as this format, create a buffer, and then I can just say return this image. Now that's really, really nifty because we've talked about egress costs. This can save you masses of money because if you are only serving a 300 by whatever the dimension is, 300 by 500 or 50 image, it is way, way smaller. It'll only be like a K, and then you use WebP instead of PNG, and it will be smaller again, and you're serving the most optimal images to the end user, and you'll have to put a little bit of error handling and stuff around, but this is a service that is natively provided in a lot of CDNs. Really, really useful and nifty trick. So that's kind of the before, and the reason you'd run that before your cache is you don't want to be resizing the image on every request. You want to serve that once. That takes us to the final compute, which runs after, which it should say after. Apologies. Get. So this is getting before the cache, and then I'm returning and hitting my edge function. Now let's say I want to kind of track users. If someone is revisiting the site on their phone and I want to kind of keep track of who is visiting, I can run after the cache because let's say I'm news website again. I don't want to associate my cache with users. So now I can cache for everyone, and my edge function can check to see if there is a viewer ID cookie, and if there isn't a viewer ID cookie, append a set cookie response to that, and then I can generate a user ID. So that allows me to kind of categorize each of these requests into like per user. That's super, super handy for attributing that to, say, Google Analytics and giving you kind of consistent, I know when a user is returning to my website to improve analytics. So they're kind of the various different types of compute and reasons that you would run compute before and after the CDN cache. So just to sum up kind of what the edge is, it pretty much just allows you to run compute in those points of presence. So rather than having to run your origin server and all of your code in a data center in Azure, where if you want to set up multi-region architectures, it becomes really complicated and the cost goes up, you can just move that compute closer to your users and leverage all of those little servers they have in thousands and thousands of points of presence around the world. And that makes a huge difference to how responsive your website is. It can run theoretically in 4 different places: the viewer request, the origin request, origin response, and viewer response. They're kind of the 4 logical places that you can run compute. Each of the clouds call these different things. This terminology is more specific to AWS, but the concepts move between the different clouds. You can also now run Astro, Remix, Next.js. You can deploy edge functions, and so it will deploy your website as functions to all of these points of presences around the world, and you don't even have to run an origin server, which is pretty nifty. There's an example of kind of the things that this unlocks. There's a new open source tool called PartyKit, and it is a SDK that's designed to help you build collaborative applications. So if you've ever gone into Google Docs or Miro, where you are collaborating live, doing like a drawing application, latency is a massive factor. Every time you draw something, it has to go back to your origin server and then deal with putting that back out to all of the end users. It can be quite slow, and latency really, really adds up and makes the feel of those products really, really crappy. So up until now, it's been really hard to build those sort of collaborative experiences. PartyKit leverages CDNs to build that multiplayer capability into your app, leveraging compute running in all of these points of presence. So you can write your own logic. It takes care of running that in all of these points of presence, plus giving you that kind of multiplayer capability. It's pretty cool project, only just come out, but it's an example of how the edge is being used to kind of further these experiences. You've got HTTP fundamentals is kind of the next thing I want to chat about, because without understanding kind of the building blocks, there's a lot of traps with caching and CDN. So let's just take a step back and talk a little bit about HTTP fundamentals, because I always like to kind of look into the what and why and kind of how we got to these areas. So HTTP has a concept called methods, for which each method has kind of different semantics associated with them. One of the semantics associated with the different methods is if that can be cached or not. So get and head requests, for instance, they are cacheable. You should always be assuming that your GET requests could be cached. And this is a reason why the best practice is never put anything in your application that mutates state inside a GET request, because if you're relying on that state being mutated in a GET request and then suddenly something caches that side effect will not be happening anymore. So GET and head requests shouldn't mutate state because they are inherently cacheable. Post is sometimes cacheable, but generally I try and make it so it's considered an idempotent endpoint, which means if you do the same thing multiple times, you end up in the same spot. And then the rest of these HTTP methods are not cacheable. So proxy, CDNs, browsers won't cache those methods. So that's the first kind of basic. There's also a heap of different type of caches when working in the web. So you've got your private cache, which is the browser. Proxies are more, let's say, your internet service provider. These were more prevalent when the web was HTTP. So they could actually store copies of web pages inside your ISP, your internet service provider, rather. So if you've got a bunch of people on a mobile network, they could cache a copy of the website and then share that cached copy for every user on their mobile network. HTTPS puts a stop to that. So that one's kind of dying a little bit. The next one is this managed shared cache, which is reverse proxies or CDNs. And the reason they can work is in terms of HTTPS, is they terminate HTTPS. So if you are using a CDN, the request hits the CDN, that's where the SSL cert is terminated. And if you're running an SSL backend, it will establish its own SSL connection to your origin server, but it always terminates at the CDN layer. And that's how it can read the content, because HTTPS stops anything in transit from being able to read that content. So that's kind of how they get around that and can provide all these caching capabilities, is by being a SSL termination point. But your website can essentially be cached by any of these. The main way you control that is with the cache control header or the CDN cache control header. They're the same header, but the CDN cache control header will only be looked at by the CDN, and then it will be stripped off and not returned to the end user. The advantage of this is that you can actually have different caching strategies for the private cache or the browser and the CDN cache. Where this is really, really handy is if you make a mistake in your caching or you're doing a new deployment and you need to stop that cache, CDNs allow you to invalidate the cache, but you can't invalidate end users' browsers. If you cache something in there, you're kind of stuffed. So what you want to do is use these headers, cache heavily inside your CDN if you can, but don't really cache inside the browser unless you know it's safe to do so. So there's quite a few different options. Private means it's only allowed to be stored in the private cache or in the browser. This instructs a CDN that it's not allowed to store this. An example of when you'd use that is for auth. If there's anything private about the user. It's like setting cookies or anything like that. Private. No store. Do not store this in any of the caches. You can also, we saw this earlier, you can say max age equals number of seconds, or you can also do S match max age, which is a shared, same directive, but it is only interpreted by the shared cache, which is your CDN. You can also specify that something is immutable. So massive max age, it's immutable. This file will never change. We'll cover kind of a nifty example of that later. And then if you are caching, you can tell the CDN that it must revalidate to make sure that its cached copy is the latest copy. So there's all of these directives in the cache control header, and we saw this a bit earlier, that allow you to control exactly how your content is cached. And this has been built into the HTTP spec for ages, and it's a really, really powerful tool. Even if you are not using a CDN, you should have an idea of these sort of cache control headers to be explicit about how your content can be stored in the various caches. The next one, if you were looking very closely at some of my previous examples, you might have kind of thought, well, how do you make sure that if I'm asking for image.png and then I'm changing the format, how do I make sure that that I'm not serving the wrong format to the wrong people? And the way you do that is with something called the vary header. So the vary header, when I'm getting my WebP and JPEG image, my server can actually add a response header called vary accept. And this essentially directs the CDN to say, I want to create a cache key which matches on not just the URL, but it also matches on the accept header. So you can kind of bucket your caches up with these different composite cache keys and use the vary header to tell the browser what additional headers that you want to cache on. Something to be aware of with here is different CDNs support this. So like, for instance, Cloudflare only supports using this for this scenario, the image scenario. It's not a general purpose for all CDNs. Other CDNs like AWS, you can use it for more scenarios. So just something to be aware of. But what this allows you to do is when I'm asking for a PNG, but I only accept the image PNG, I have a different match requirement. So now, when my first one comes in, it will match the cache from the first request, not the second request, because I've varied on the accept header, and it uses the accept header to figure out which version of the cached response that it is going to return. So that's vary header. There's a bunch of others that I won't go into, like last modified, if modified since, and this is around if it can fetch updated, or if the content has changed, rather. E-tags are another method around this, where you can hash the content, and it can efficiently say, this is my last e-tag that I knew about. If the server has newer content, it can then say the content has changed and send the response. Otherwise, it can just say, yep, you got the latest copy, use the copy in your cache. So there's a bunch of other tags which are pretty handy. Fundamental summary. Get head requests, cacheable. Post sometimes can be cacheable. Other methods are not cacheable at all. So be specific in which HTTP methods you're using. They can affect a whole bunch of different things and have different semantics. The cache control headers allow you to instruct all of these various proxies and caches that exist on the internet, how they're allowed to store your content, and the vary header is used to kind of segregate into multiple cached copies or make it more specific. Now, tips, tricks, and gotchas. There's some interesting ones, and here are kind of my favorite examples of where you can use it. So cache-busted URLs, if you use a JavaScript build tool or any sort of web build tool, you've probably noticed that, like Webpack, for instance, produces files that look something like this. It's got like the chunk name, and then it's got a random string. Now, the whole reason around this is for making these infinitely cacheable or immutable files. So generally, this is what you instruct the build tool to do, is create these static assets as chunk name dash file hash. A hashing algorithm is a one-way transformation of the file, in this case, the file content, to a string. So if the file content changes at all, it will end up with a different suffix on the URL. So that means that if for any given URL, it can only have that exact content, which means I can instruct the CDN and the private cache that this file can be cached forever. Really, really handy, because then the private cache on the website, when they re-return to your website, won't even hit the CDN. It will keep copies of all of your static assets. So this is something that's super, super handy, and you should be taking advantage of, because egress costs still cost on your CDN. It is still cheaper to not serve any traffic. So cache busting all of your static assets can save you a bit of money if you've got any kind of volume of traffic. Has anyone had an issue or seen in the news where a website suddenly you're like logged in as a different user? Has anyone had that happen before? Yeah, I've had it happen. It sucks. These are kind of one of the worst security incidences you can have. But it basically comes from, if you set a cookie on your response from your server and you have caching set up, you are going to end up with a bad time. What it's actually called when this happens is cache poisoning. So you have inputs to your request. Those are kind of the URL or the accept header or various other things. That makes up your cache key. If your origin server is looking at more information on that request, like you aren't caching, or you're not saying the authorization header or the authorization cookie is part of the cache key, and then you are looking at the user cookie on the server, you are going to end up with a bad time. And so some of the rules to get around this is make sure your origin server is only looking at stuff in that request that is part of the cache key. And what that allows you to set up is, let's say you've got your callback endpoints for OAuth. Those should set all of the no cache private cache control headers to just say, this can never be cached because I'm looking at a whole bunch of user-specific and request-specific information that I don't want to have. So when users get logged in as someone else, all that's happened is the server has got a response. It has gone, okay, I'm going to set the auth cookie for this user, sets a set cookie header. That then gets cached by the CDN. Next user comes in, gets the cached response. It's still got that set cookie header. Now the second user that's come along has got that auth cookie for the first user. That's cache poisoning, and it's incredibly easy to do as soon as you have a cache in front of your website. So it's one of the biggest call-outs, and if you take anything away from this talk, it is make sure when you start playing around with the caching that you're really, really careful around anything to do with auth, and if you are setting cookies. It can be, once you set that cache, as I said, if it ends up in the browser cache, it's very hard to get rid of. So when we did it, we actually had to write code which we deployed to our application that went and found these poisoned cookies and deleted them from the end user's browser. So it's one of those ones that are super, super annoying, and you see these post-mortems from different companies that are having it probably every 12 months or so. So it is a reasonably common problem. The other thing is, as I said, caches get requests should be cacheable. And so if there is a body attached to the get request, don't look at it. Like generally, one of the cache poisoning attacks that people do is if you can put anything in any header, like a value, and then that value is included in the response. So any inputs of that affect the response, but that input isn't in the cache key. that is when you are opening yourself to a cache poisoning attack. So just make sure you kind of line up whatever your request on your origin server is doing, make sure that's lined up with your cache key in your CDN. The other really nifty thing that I often do is I have a single page application. Let's say we're running Next.js. One of the problems is you often bake your config into the build process, which means if you're deploying to dev needs to know where the API is to be able to make API calls. You generally provide that as an environmental variable at build time to your Next.js application that gets included into your bundle. A really nifty trick is I can include a script tag to config.js inside my HTML that I return. So get index.html to the CDN. It goes to my static file server to return that HTML file. I'm going to configure some path rules that basically say, okay, for config.js, route that request to my API. So the browser doesn't need to know what the URL of my API is. My CDN knows what that is. So when I get my config.js, it can hit my API, and it can return a route that looks something like this. I realize that might be hard because of the screen that's low, but this request essentially returns a JavaScript file, and I've put some JavaScript in the response, which is window.content equals API URL equals the URL of the API, and then whatever other config that you might want, because it's far easier to manage config inside a server rather than these static websites. So this is a trick I use a lot to give my config to my to my single page application. And so essentially your API can just return its own URL to the front end. Now anywhere in my front end app, I can just go window.config.api URL and use that for my fetch requests. Super simple example of how you can use that flexibility of the CDN and multiple origins to get a really nice outcome. The other thing you can do with this scenario is you can map /API to your API origin. And I'm sure if you do web development, you've hit cause errors before where you can't call your API. Well, if you're just mapping a path to your API, cause problems go away because it's all the same domain. It's not cross-domain anymore. Cause issues disappear. So some really nifty examples of how you can just use path mapping, routing to different origins to get away from some really annoying problems. So that's been CDNs 101. I hope you had a few takeaways there, and it gives you kind of the tools in your toolbox to navigate what I found a pretty daunting subject when I first got into playing with them. I'd built line of business applications before, and CDNs were just kind of this thing that I'd heard about, like Akamai have some delivery network, and didn't really understand what it is and how to use it. And then throughout various projects, I had to learn to make use of CDNs and realized how valuable a tool they are. So that's been CDNs 101. Thanks everyone for rocking up at 9 a.m. on a Thursday, but thanks very much.